Hello everyone, I am Dr. Sudhansh Sharma from School of Computer and Information Sciences, and I welcome you all to this session of BEY 020 Computer Basics and PC Software Skills. And this session is about unit number 3, that is memory systems. The objectives of today's session are to understand about the different type of memories, and in this session we are going to understand about what is the difference in between the different types of memories. Apart from this, we are going to learn what a memory system is, and we are going to cover the memory hierarchy and how access time, cost per unit of storage affects and creates the memory hierarchy. So to begin with, let's start with the session objectives. The objectives of today's session are to understand the different type of memories and need of the memory system. Apart from this, we are also going to understand about the differences between the different type of memories, be it semiconductor memories or optical memories or magnetic memories. We are going to learn all this in this session. So in our previous sessions, I think you had already learned about that that a modern computer system is composed of 3 units. We are having an input unit, we are having central processing unit, and the output unit. The input unit is composed of keyboard, mouse, and all those devices which are required to provide data for processing to the central processing unit, which is comprised of 3 subsections: the memory unit, arithmetical logical unit, and control unit. Whatever the data is being processed is being passed on to the output unit, which is comprised of, say, monitors or printers or any other output device. There are many output devices nowadays. So this is the basic structure of the modern computer system, and the memory unit and arithmetic logical unit and control units are exchanging the data, which is being shown by the direction of the arrows. And in this session, we are going to understand what the memory unit is. So we all need to remember something. So in order to implant the concept of remembering or forgetting the things to the machines, we need to have the concept of the memories. And memories are storing the data in the form of the bits. So bits are 1 and 0. Now, do we have numeric 1 or 0? No. We are having the voltage signals. So the devices are supposed to work on the basis of the voltages, and there is some threshold voltage beyond which the value is considered as 1, and below that it is considered 0. So say we have a 5-volt device, then any voltage which is above 3.5 volt will be considered as 1, and below that will be considered as 0, and there are noise regions also. So in order to store the data, we are supposed to store the signals in the form of the voltages. So that's why we are having different types of memories. We are having memories which are based on the capacitive circuits. We are also having memories which are based on the flip-flops. So they are categorized into the category of the semiconductor memories. Apart from this, semiconductor memories, we are going to learn in details about that what semiconductor memories are. They are quite fast but expensive. But we need to store voluminous amount of data, and that's why we need to have different types of memories which are classified into the secondary memory segments. The semiconductor memories are identified into the primary memory segments, and we are also having other memories in the primary memory segments. We are having cache memories, we are having registers, and registers are faster than cache memories. Cache memories are faster than primary memories, and they are all comprised of the semiconductor memories. But the secondary memories are frequently using the concept of the magnetic memories and the optical memories. So we are going to understand how the volume of the storage, apart from the access time of the memory, relates to the memory hierarchy. So to just begin with, in order to formally understand what the memory unit is an important component of the computer where all the data and the information is stored in the form of binary digits. So you need to understand that there is a difference in between the data and information. The information is the processed data. And wherein the data is being processed? The data is being processed in the central processing unit. the data is supplied by the input segment, which is generally a keyboard or a mouse, and which is being processed, which is firstly stored into the memory unit and then passed on to the control unit and arithmetical logical unit to perform necessary operation, and then whatever information, that means whatever the data is processed, is transformed into information, is passed on to the output units. So the functions of the memory unit are primarily to store the programs and to store the results of the computation. And this storage of the data, as we had already discussed, that is in the form of the bits and the bytes. And you can understand, and you might be using it because day in and day out we are using mobile phones, we are using laptops, and there are different levels of the memories. Likewise, we are generally having secondary memories, hard disk, external hard disk, in the format of terabytes. So we are coming across the day in and day out about the terminologies like gigabytes, kilobytes, terabytes. So kilobyte is 2 raised to power 10 bytes is kilobytes, megabytes is 2 raised to power 20, and so on and so forth, 2 raised to power 40 raised to the terabyte. So this is all related to the amount of information that can be stored into the memory. So based upon the access time and the storage capacity and cost per bit of the storage, we are classifying the memory into two main classes, that is the primary memory and the secondary memory. The primary memories is, as we had already discussed, are the semiconductor memories, and which are further decomposed on the basis of their speed of performance as the registers, the cache memories, and the RAMs and ROMs also. Apart from this, as we need to store more and more data, so the cost should also be less, so we need to have alternative, and that alternative part is being provided by the secondary memory, which is generally classified into two sub segments, that is the magnetic memory, which may be a magnetic tape or a magnetic disk. We are not using floppy disk nowadays, but gone are those days, and we are nowadays sometimes we are using compact disk, which is lying into the field of the optical memories. So CD-ROMs, DVDs, all are classified into the category of the optical disk, which is a class of the secondary memories. But nowadays we are frequently using flash memories, that is your pen drives. We are using external hard disks, which are excessively used as the secondary storage of devices. So so far as the parameters, that is your access time, your storage capacity, and cost per bit of storage is concerned, the classification says that the primary memories are much faster in context of the access time, but their storage capacity is small and cost per bit of storage is on the higher side. So far as the secondary memories are concerned, the access time is slow. We will be also classifying these memories on the basis of the type of access. We are having direct access memories and the sequential access memories. As the session proceeds, we will be covering that part also. So the secondary memories are slower on the part of the access times, but their storage capacity is high and cost per bit of storage is on the lower side. So there is an advantage of secondary memory and there is advantage of the primary memory also. So if we want to have higher processing speed and we want that the result should come fast, we should focus on the primary memory segment. But if we want that the storage, the voluminous amount of data should be covered, we should have proper backup of the data, then we are supposed to focus on the secondary memory. So we need to have the balance in between the primary memory and the secondary memory. If we go to the field of the operating systems, wherein the memory management sections come into the picture, we are having the numericals of hit and miss ratio, wherein we generally learn that how much memory is suitable for which level of processor. So it is not like that we can install, say, we can have terabytes of the RAM. No. So there are calculations, there is a level of understanding. We are not going to touch those things, but we need to have the balance in between the amount of requirement of primary memories and the requirement for the secondary memories. Now, so far as the storage part of the data is concerned, we are classifying the data, that how the data is to be holded into the memory, because memory means to hold the data. and to also unhold the data, so we are having a positive logic and a negative logic. So positive logic says that 1 is memory, and negative logic says that value 0 is memory. But we are on the basis of the storage of data, we can classify the memory into two segments, that is a volatile memory and non-volatile memory. The RAM, random access memory, is a volatile memory because when we shut down the computer, whatever the data is available into our random access memory is being lost. But when we switch on the computer, it is automatically identified that the BIOS are going to identify that firstly the drivers are to be installed, then the operating system is to be installed, then application softwares are to be installed, and when we shut down, the application softwares are to be uninstalled, then application softwares are to be uninstalled, then operating system is moving out, after that drivers are being unloaded, and then the system comes into the shutdown state. So some amount of the data is required to be stored into the memory even after the computer is shut down. So that's why we need to have volatile memories and non-volatile memories. So based on the retention of the data, we are classifying the memories into two categories, that is volatile memory and non-volatile memory. And a non-volatile memory is a type of computer memory which can retain the stored information even after computer is shut down. And the example of non-volatile memory is read-only memory. So random access memory, that is RAM, is volatile memory, whereas read-only memory or flash memory, optical disk are your non-volatile memories. So as we had already discussed that we are having the hierarchy of the memory based on the requirement of the access time, so and the storage capacity. So we are having semiconductors memory as a primary memory, and we are having secondary memory which is covering up the memories like magnetic memories, optical memories, flash memories, and they all are being segmented on the basis of their storage capacity and speed of performance. So the highest speed of performance is being achieved by the registers which are available into CPU only, and thereafter the second memory is your cache memory, which works as an interface in between the registers and the primary memory, which is your random access memory. Thereafter the data is being passed on to the secondary memory, which may be your hard disk, and we are going to discuss about the structure of the hard disk in this session, that what do we mean by the tracks, what do we mean by the sectors, and how the storage of the data is being happening into the hard disk. And thereafter we may have the USB ports wherein you can connect your external devices, likewise your external hard disk, which may be holding the data in the form of say terabytes, or you can have your optical disk, likewise your CD-ROM or DVD, and so they are classified into the category of the non-volatile memory, whereas RAM, cache and registers are categorized into the category of the volatile memory. So so that's why we are having a memory organization, and this chart depicts that how the memory organization is on the broader side performed. And as we had already discussed, that it is the cache memory which acts as an interface in between the main memory and the CPU. And CPU contains the registers, and cache memory is on the faster side, but it is slower than the registers and acts as an interface in between the main memory and the registers. Now so far as the pyramid of the memory, because we are having the hierarchy of the memory, as we had already communicated, that there are parameters like your access time, storage capacity and cost per bit of storage. The pyramid says that on the top we are having registers, thereafter we are having cache memory, then main memory, that is your RAM, and after that we are having magnetic disk, virtual memories, you can have magnetic tapes. And so the direction from bottom to top, that means the memory is moving from slower side, slower access time to faster access time, and storage capacity is small in case of registers, but it is large in case of magnetic and optical memories, whereas registers are quite expensive and the magnetic memories and optical memories are quite on the reasonably cheaper side. So these are the parameters on which we had classified the memory, and this is what is known as the memory hierarchy. Now, so far as the access time is concerned, generally registers are taking 0.5 to 2 nanoseconds for the processing of the data, and cache memories are taking 0.5 to 2.5 nanoseconds, and RAM is taking 50 to 70 nanoseconds, whereas mass storage devices likewise or magnetic tapes or optical disc are taking 50 to 20 milliseconds. So the access time, the graph shows that the access time is continuously increasing as we move from the primary memory segment to the secondary memory segments, that is from the semiconductor memories to the optical memories and other parts of the secondary memories. Now, just to tabulate and to brief what we had covered up till the time, we are having three commonly used memory technologies. One of the technologies is semiconductor memories technology, which is electronic in nature, and it has got random or direct access mode. As we had already said that memories are using direct access mode and the sequential access mode. What do we mean by direct access mode and what do we mean by sequential access mode, we are going to discuss just now. But as of now, the access mode for the semiconductor memories is direct access or random access. They are volatile in nature and their access time is quite low, and their average cost per bit is on the higher side. So far as the magnetic memories, the storage capacity, the nature of storage is magnetic in nature, and they are using a sequential or a random access, sequential access, and they are non-volatile, and their access time is comparatively higher, and average cost per bit is lower in comparison to the semiconductor memories. And on the same line, the technology which is being used by the optical memories, they are using the optical laser beam mechanism to store the data into the memories, and again their access mode is random as in the case of semiconductors, and they are also non-volatile. Comparatively, their access time is on the higher side and average cost is comparatively low. Now, this figure shows that the sequential access is that if we want to go to number 5 in any sequence, then we need to traverse all the data altogether, say 0, 1, 2, 3, 4 and 5. Then only we can cover up, we can access the data 5. But in the direct access memories, the read and write head can directly point to the required section of the memory, and that's why the direct access memories are able to access the data in no time. So the magnetic tapes, may you recall the times when we were having audio cassettes and we were having floppy disks. So the audio cassettes, you need to rewind and you need to forward the song to move to that particular song. But when we are using the CDs, we can directly choose which track, and directly the head, read and write head, can point to that head and we can access the data directly. So the optical disk on the secondary memories are using the facility of direct access. Apart from this, the semiconductor memories are using the mechanism of direct access to access the data. But the magnetic memories, magnetic tapes specifically, are using the concept of the sequential access of data. It is very important to understand the mechanism to access the data, because that affects how frequently we can access the data. We are going to learn about the different concepts in our subsequent sessions, that what do we mean by the latency of the data, seek time of the data, and how they are being calculated, how they are related to the performance of the system, and these all topics will be covered in our series of the sessions which we are going to take. But in this session, firstly we need to understand the different type of memories, and after understanding the different type of memories, we need to understand the differences in between them. So this is the classification map of the entire main memory mechanism which we had learned till the time. The main memory is classified into random access memory and read-only memory, and we had learned that the random access memory is volatile in nature and read-only memory is non-volatile in nature. But the RAM is further classified into DRAM and SRAM, dynamic random access memory and static random access memory. And ROM is classified into PROM and EPROM, and we are having EEPROM and all those things. Programmable read-only memory, electrically programmable read-only memory. And these memories are classified also on the basis of the category that can we only read the memory, or we can read or write the memory. The read-only memories are non-updatable, whereas read and write memories are updatable. That means you can refresh the memory and you can update the new data onto the memory segment. So RAM is classified into the category of read and write memory, and it is volatile in nature, and the mechanism to read and write the data into the memory is on the electrical basis. But ROM is read-only memory, and it is a non-volatile memory. You need to store the data permanently, so that as and when the systems is reopened after shutdown, the system can be reinstantiated into its required state. And it uses the mechanism of masking, and erasure is not possible in the case of the read-only memory. Apart from this, PROM and EPROM and EEPROM are again classified into the category of read-only memory, and all are non-volatile in nature. And the mechanism they are using is of the electrical mechanism in the case of programmable read-only memory. So these are read-only memory, so storage of data is permanent, and the erasure of the data is not possible. But when electrically erasable memories are there, we can electrically erase the data and rewrite the data for further purpose. So there are broadly we can compare random access memory and read-only memory on the basis of the data retentions, type of storage, and read and write capability, speed, purpose, capacity. And so far as the storage capacity or the type of storage of the random access memory is concerned, it is temporary and volatile, but read-only memory, it is permanent and non-volatile storage. And the first and the foremost, you need to understand that random access memory is volatile memory, which is used for the temporary storage of data. Because we need to so as to understand that, say secondary memory is the ocean. Then we so as to process the data, say we pick up a bucket of water from the ocean. This bucket of water is taken care by the random access memory, RAM memory. Then we draw a tumbler of water from that bucket, that is taken care by the cache memory. And later on, small amount of water is being used for say to give to the plants. So that means that is the register. So it is the register which is finally passing on the data to the processor to get it processed. Once the data is processed, it is repassed on to the secondary memory in the same mechanism, that is first passed on to the registers, then to the cache memory, then to the RAM, and then to your secondary memory. So we are having the data structures also. The data structures is a very important topic in the field of computer science, so as to understand how the memory systems, how the data is being handled into the memories. We are having AVL trees, height balance trees, and different B trees, and different type of heaps, and different mechanisms are there to handle the data, to structure the data, to store the data, to manage the data. So, so far as the broader concepts are concerned, the memory is passing on. So, permanent storage of the data is happening at the secondary memory part. But in the RAM and cache and registers, the data is flushing in and flushing out. So, that means the RAM and cache and registers are of the segment volatile memories, and they temporarily hold the data. And as the power is switched off, the data is lost by these memories. But so far as ROM is concerned, even if after the power is lost, the data is still present into the memory. So they are non-volatile in nature, and they store the data in the permanent manner. So that's why we are also having SRAM and DRAM. As we had already said that we are having the concept of the flip-flops, and we are also having the mechanism of capacitors. So SRAM, that is it is comparatively fast, and it requires the mechanism of flip-flops to store the data, whereas the dynamic RAM stores the data in the electronic format in the form of the charges in the capacitors. So DRAMs are actually related to the capacitive memories, and flip-flop based memories are your SRAMs. So we are having the magnetic memories. There are the limitations to the semiconductor memories, that semiconductor memories are having limited capacity and they are volatile in nature. So the magnetic memories are non-volatile in nature, and they can store the largest capacity of the data. And that's why the modern computers are using magnetic disks and magnetic tapes as the components for wider storage of the data. So we are having the magnetic memories, likewise floppy disk, and the CD-ROMs and DVDs, wherein the data is being stored in the tracks and the sectors, and the tracks and sectors are shown into the figure only. And in the upcoming sessions, we are going to understand that how the data is being stored in the tracks and the sectors, and we are also going to explore that how the hard disks are composed, what is the cylindrical structure of the hard disk, how the data is stored in the tracks and the sectors, and how the data is being accessed. We are also going to cover up about the numericals required for the calculation of the memories. And this is all about this session. I hope you are able to understand that what are memories, what is the classification of memories, and what is memory hierarchy. And in the subsequent session, we are going to learn about the details of the hard disk and perform some calculations also. Thank you very much.